Welcome everybody. Ladies and gentlemen, welcome to the technical stage of Hydrogen and Fuel Cell Europe of the Hannover Fair 2021. My name is Bernhard Jekyll. I am the moderator for this day, and we present you lots of interesting presentations, information about the newest technology. The next presentation will be about multi-channel EIS characterization of high-power fuel cell stacks. And we have the chance to see it here, the CEO of Kolibrik. It's Dr. Jirí Libra. Come to the stage with an applause.
Dear ladies and gentlemen, I'm glad to welcome you on my presentation and take this opportunity to introduce our company and the newest results of our development and of impedance spectroscopy measurement on fuel cell stacks. Our company generally develop and producing electronics for the hydrogen field, and just quick introduction. We are helping our customers with our electronics and software solutions with fundamental and applied research. We are developing testing equipment mainly for the impedance spectroscopy for fuel cells, fuel cell stacks and electrolyzers. And we have also electronics for rapid prototyping of automation of test stands and mainly application, cell voltage monitors and so on. And we are also cooperating with our customers and develop for them custom electronics for applications in hydrogen field. Very quickly, few photos of our product families. Most famous product is our cell voltage monitor product family. It's made from small credit card size PCBs. It's compact and modular. We have more modules with different specification, and we are doing also customized modification, custom cables and so on for our customers. We also developing DC-DC converters for hydrogen applications. Let's say at this moment in some middle range of power up to 10 or 20 kilowatts. There is also some picture of custom controller for hydrogen application. And today I want to talk mainly about our testing equipment. We have several product families for investigation of hydrogen fuel cells, for short stack, long stacks, from small powers to high powers. We started with potential starts and continue with development of electronic loads, and for we get in the time to higher currents and powers as researchers have and engineers have demands for higher and higher power of the fuel cell stacks. So I would like to say a few words around about impedance spectroscopy, because it's quite a nice method which can provide very detailed information, a very detailed characterization of fuel cells. Important feature is that this measurement can be done under operation. That means that you can operate your stack in normal conditions, and during that you can measure impedance spectroscopy of each cell, and it can provide very nice information about state of yield, cell degradation, internal resistance, and so on. It's very complex topic, so if you are interested in then I would like to invite you to our booth, which is there next linked. And we have here also our scientific consultant, which has everything about the impedance spectroscopy. So he can discuss with you about such topics. I would like to say a few words about the story, how it started and how it evolved. It was about 1 decade ago when the researchers came and they said that they want to investigate their small fuel cells and they want to build up testing laboratory, and then they want some cost-effective solution for impedance spectroscopy, and not only impedance spectroscopy but general characterization of fuel cells. So we started then with development, and first we developed potential stat, which was made. First specification of our customers was for 10 amperes, because they started with really small fuel cells, around 5 square centimeters. So we finished such development, and then the researchers came and said, great, that's nice, we need to add some more features, but we also need higher current, we need 50 amps, 20 amps. So we make some modifications and we make the first generation of our product that were sold in testing laboratories and test stands. And then researchers came again and told that it's great, but they need more. They need 50 amperes, 100 amperes, and so on. So we said okay, and we developed new generation of electronics, because we need to make redesign to take much higher power. So we make potential cells that can handle up to 100 amperes, that can dissipate up to 1 kilowatt of power. And those potential cells can measure impedance spectroscopy at least up to 100 kilohertz. So then researchers come and tell that it's great, that it works well, but they have big automotive cells that can do more than 1000 amperes in laboratory conditions. So we said okay, and we started with development. We developed electronic loads modules, because with big fuel cells you need high current just in one quadrant. And so we developed solution for it is modular solution, so we can make customized devices that can handle from, let's say, 200 up to 2000 amperes. They can measure impedance spectroscopy in the load mode, and they have also zero voltage features, so we can investigate single cells, and we can even draw full current from the short circuit on the output terminal and measure impedance spectroscopy in it. And so this was next step of our development. And then researchers again say that it is great, but they want higher power, and this solution starts to be a bit expensive if we are just adding more and more modules. So we developed the possibility of connection of external DC load, which can boost the power. The external load just takes 90% of the power, and the rest of the power can be modulated by sinus wave, and so that the impedance spectroscopy can be measured again up to let's say 100 kilowatts. So we ended up with second generation of our products that can measure single cells, short stacks, and full stacks up to, let's say, 100 cells, up to 2000 ampere, and let's say up to 20 kilowatts of internal power dissipation that can be boosted by external loads. And this solution uses just 2 voltage probes for ACE measurement. Mainly one is used for measuring the whole stack, and the second is for measuring of selected cell. So then researchers come again and said that it's a very great solution, but they finally have big fuel cell stacks. They want to measure them, and they are really interested in the impedance spectroscopy. But if they have hundreds of cells, they don't want to wait several days for measuring each cell by one. And so we again started with development, and this is our last product family and newest results. So we now have again modular solution of electronic loads that can work up to 1000 volts. So you can investigate fuel cell stacks up to 1000 channels. It can again handle up to 2000 amperes. It can be boosted by external DC load, and the main key feature is that we can measure up to 1000 channels simultaneously, and so the impedance spectroscopy analysis will be quite fast. This third generation is it uses completely different electronics. We use one of the biggest ARM microcontrollers. We use programmable logic arrays. We use the best-in-class existing sigma delta ADC converters to provide most precise measurement in very fast sample rate, more than 1 megasample per second. And we also redesigned the signal generator, so we can extend features to another methods, because not just sinus perturbation can be put in the circuit, but any other arbitrary waves, like simulating of ripple of DC-DC converters and so on, and we can measure general oscilloscopic measurements. So this I will just show you quickly one sample configuration. Okay, so just look at the pictures, and if you will be interested, then come to our booth, and we can discuss all the details, because it's very complex topics. So thank you for your attention.
Okay, just stay a second. Thanks a lot for this presentation. We have no more time for a question, but I would like ask one question. How did the Kolibrik inspire your name, your company name?
Company name? Well, it's Kolibrik. Well, the Kolibrik means in English is human bird, but you see in the logo, and it's related to my name. It's, let's say, my nickname from childhood.
It's your nickname.
Yeah, it's my nickname. So,
okay.
And I started as a freelancer, so I used the name, and then the company was transferred to limited company, and but the name remains the same. So.
And the Kolibrik is not only very small, but he's very quick. It's very quick and can stay in one spot and can fly backwards also.
Thank you.
Okay, thank you for this presentation.